Here's another well video. It's a continuation of a series of videos. This is part 284C3m1b7a3. Line 22f1fa19c3m1b7a3. Vanadium dioxide terahertz radiation metal transition 5G Wow Seti. Okay, and this is a keyword research video. So there's the alien radio signal. And November 23rd, I was doing the research. Today's the 25th, 2012. So I'm going to Google the keyword terahertz radiation waves from the previous video, which is line 22f1fa19c3m1b7a2 laser mixing electron hole collision waves 5G Wow Seti. So quotes in Wiki: terahertz radiation. In physics, terahertz radiation, also called sub-millimeter radiation, terahertz waves, terahertz light, T-rays, T-waves, T-light, T-lux, or THZ, consists of electromagnetic waves at frequencies from 0.3 to 3 terahertz. Terahertz radiation occupies a middle ground between microwaves and infrared light waves, and technology for generating and manipulating it is in its infancy, and it is a subject of active research. It represents the region in the electromagnetic spectrum that the frequency of electromagnetic radiation becomes too high to be measured by directly counting cycles using electronic counters, and must be measured by the proxy properties of wavelength and energy. Similarly, in this frequency range, the generation and modulation of coherent electromagnetic signals ceases to be possible by the conventional electronic devices used to generate radio waves and microwaves, and requires new devices and techniques. Quote, things to remember. Terahertz radiation is strongly absorbed by the atmosphere, limiting communication distance. We'll have to look at formulas in the well videos to see if there are ways to change that. Terahertz radiation has limited penetration through fog and clouds and cannot penetrate liquid water or metal. As of November 23, 2012, I'll do more research to see if this has changed. Google terahertz radiation penetrates water and metal. November 23rd, I can see this being used in the UFO spaceship formula somehow. So this is an image showing a scanning electron microscope image of a damaged vanadium dioxide in the gap of a terahertz metamaterial made of gold. The damage results when strong field enhancement of incident terahertz radiation in the gaps leads to a rapid increase in the energy density following the field-driven insulator-to-metal transition. Credit image by Mengun Liu and edited by Mario D'Amato. Quotes from various paragraphs on the blog. Terahertz radiation can induce insulator-to-metal change of state in some materials. And this is from ScienceDaily, July 25, 2012. A team of researchers at Boston University, Massachusetts Institute of Technology, or MIT, and a number of other institutions recently observed that certain materials undergo an insulator-to-metal transition under the influence of terahertz radiation. The study, under the direction of Richard Averett, professor of physics at Boston University, and Keith Nelson, professor of chemistry at MIT, was published earlier this month in journal Nature. The research team achieved a first by demonstrating the use of THZ, light pulses, to control the phase, state of matter, of a material. In this case, the researchers were able to change vanadium dioxide, VO2, from an insulating electronic state to a conducting electronic state. Sorry, I lost my place here. Okay, so says Wang, sub-piosecond THZ pulses can allow us to initiate strong changes in a material. In the case of VO2, the THZ pulse actually distorts the potential in which electrons lie, freeing them up to make the material a better conductor. However, to do this requires very strong THZ fields. In this case, the researchers used an antenna-like structure called a split-ring resonator to concentrate the electric field of a THZ pulse in a small area, increasing the electric field from hundreds of kilowatts per centimeter to about 4 megavolts per centimeter. And that's from ScienceDaily.com. Okay? So the keywords to Google sub-piosecond THZ pulses and split ring resonator are going to be in the next video. Thanks for watching.